All right, it's about 6:30. It's time to get the Fullstack development meetup going. My name is Josh Peck. I'll be your host for the evening. Our format tonight is going to be two 15-minute talks, one presented by Mark Volkmann, and he'll be talking about catching up with ES6, and then Chris Oliver will be talking about Rails in the stack. So we're very excited to have both these guys here and presenting this evening. Just to give you a brief overview of what our goals are for this meetup and this event tonight. My name is, I told you my name, I'm Josh. I work for a company called Akezo. We've got the domain name fullstack.org, and we are creating a series of meetups across the country, perhaps across the world. This is our first one in St. Louis. We'll be starting one in Honolulu. Likely New York and Tokyo are next, so if you have friends in those regions, please let them know. You can find more information about the events at fullstack.org as well as the St. Louis meetup site. And we're also on Facebook and Twitter. So if you've got good things to say about the event tonight, feel free to tweet out and mention us. If you didn't have a good experience, then just quietly mumble to yourself about it. So we are a meetup for designers and developers. There's no pitch, there's no selling. We're here just to expand the community, to educate people, and to build goodwill among developers and make better user interfaces and better applications for everybody to use. So that's our goal tonight and going forward. And with that, I think I will turn it over to Mark. He is a partner at OCI. He's been on the St. Louis development scene for at least 20 years. Working in everything from Java to JavaScript, XML. He'll tell you about some of his experiences shortly, I'm sure. But I will get him going up here. And thank you all for coming. Appreciate you coming out tonight. Thanks, Mark.
All right, well, this is going to be a big challenge for me. I have never given a talk of only 15 minutes. I have trouble staying within an hour a lot of the time. I have to say I'm very happy that Jeff Barczewski has shown up tonight because he's been using ES6 as long as I have. So I can just give the talk, and if you have questions, I'll let Jeff answer all of those. So there's a lot of great things added to JavaScript in ES6. And you can use these in current browsers. Boy, the browser support is really good for these features now. And if you need to support older browsers, you can use a transpiler like Babel to support that and have it compile your ES6 code to ES5. And so here's a short list of the features I'm going to go over tonight. There are more of them, but the other features are more complicated, so I couldn't fit those into a 15-minute talk. Many of these features are just syntactic sugar for things that you could already do in ES5. But these are great pieces of syntactic sugar that would really pain me to go back to having to write code that didn't take advantage of these. And so the first one is block scope. So instead of declaring variables with a var, now you should use let or const, really everywhere. And you can set up your linting tools to catch you in this so that if you use a var accidentally, it'll tell you to change it. People have different opinions about this, but I'm of the camp that says if you have a variable where you assign it a value and you never change it, it should be const. And so most of my variables are const, and the linting tools can tell you about that too. It'll say, you said this was const, but I see you're changing it, you better make it a let, or you made this a let, I see you never changed it, make it a const. So I really like that. So the other difference is that let and const have block scope, and that means a few things. The obvious one is that if you try to use a variable outside of the block where you've declared it, that's going to be an error. It also means that if you try to use it ahead of where you've declared it, even if you're in the same block, that's going to be an error. In both of these cases, the variables are not hoisted. Hoisting means that it takes where you've declared it and pretends like you really declared it up at the top of that block, and then you're allowed to use it before it gets to the declaration. That's just kind of weird, and so you can't do that with these. Another nice thing is that if you're doing this inside a JavaScript module, which is a whole other topic that we can't get into tonight, but in that setting, let and const variables have file scope, and that means they're not just global by default. You can safely declare these variables outside the scope of any function and not worry that it might conflict with something in a different JavaScript file. So here's a quick example of making use of this. Here I'm declaring this constant name and the variable age, which I can change because I used a let. And here I'm trying to print out their values, but I can't do that. You can't reference them before you hit the declaration. And here I can bump up the value of age because I used let, but when I try to assign a different value to that constant, that's an error. Another thing that gets people is that you might have declared a variable to be const when its value is an array or an object. That means you can't change it to refer to a different array or an object, but you still can change the content of it. You just said you can't change it to point to a different thing. Okay. Default parameters are a new thing. So when you're declaring a function, you can say that some of your parameters have default values, and there's some pretty fancy things you can do here. Your default value can refer to earlier parameters so that you can compute it based on those. And you can even call functions to get the default value. And that's kind of what I'm doing here. I created a date object, and then my function allows me to specify a day and a month and a year. But if I only specify the day, I have defaults for the others. It will just take the month of the current year and the current year. And so I'm using it in those three forms you see, not always supplying all of the parameters. Another interesting thing is that you could take advantage of the way this works to say that a parameter is required. And this is, I think, kind of an accidental side effect of the way this worked out. In this example, I have this function req, short for required, and every time you call it, it just throws. And then I say that a call to that function is the default value for my parameters p1 and p2. It will only call them if you didn't supply the value, which is what I want to happen. That's an error. So that's a cool kind of side effect of the way that works. REST operator is a way for you to grab up all the rest of the arguments. So I have this function report with two named parameters, but I could pass as many as I want. And this ends up being a replacement for our old use of the arguments object, which was our way to get to a variable number of arguments. And so here in this report function, if I call it with two things, what's really nice is that the value of colors becomes an empty array. It's not undefined. And so in my code, I can check for that. I can be sure that that will be an array, empty or otherwise. And if there are 0 things in it, I want to say that as far as I know, that person doesn't like any colors. But if I had at least one thing in there, well, that meant that they passed 3 things, the first name, the last name, and one color. And so I'll say that that person likes the color, and then the first thing in the array. And if it was more than that, I'll join them all together with the word and so you see down here the results that I get. So this is now the preferred way to write a function that accepts a variable number of arguments. The spread operator works on anything that is iterable, another big topic that we could spend a lot of time on. But for now, I'll just say that arrays are iterable. You can iterate through the elements in it. And strings are iterable over all of the characters that are in the string. And so here, I can use the spread operator to say, I want to take this array and essentially explode it into the individual pieces. So I have this array with a 1 and a 2, an array with a 3 and a 4, and I want to take the 3 and 4 and add them to the end of my first array. And so I can do a push. Push lets me pass it individual things, but I have an array. I want to explode it and treat it like it was individual things, and that works out great. Also, if I want to call a function that wants separate parameters, but I happen to have all of my values already in an array, I could explode it in place like that, and I'm passing these individual things to that date constructor. Another interesting use is using this inside a literal array. So I've got my array with bar and baz, and what I'd like to do is insert that right in the middle of this other literal array, and so it explodes it in place, and I end up with this array. Okay. And this ends up being an alternative to using a push like this. In this last example, I wanted to add these 2 things to the end of the array, but another way I could do it is say, build me a brand new array that begins with what I already had, and then I tack on 2 more, and I assign that array into over the original one. destructuring is one of my favorite new features, and it comes up more and more in my code. What happens here is that you take something on the right side that is iterable, remember that's like an array or a string, and I want to extract some things out of it. That's what destructuring is doing, is picking pieces out of a thing. And so this says, take the first and the second thing and create these variables. Now, if what was over here had 5 things, I just got the first 2. If it only had 1, var2 would be undefined, and if it had nothing in it, well, both of them would be undefined. Kind of unfortunately, if this was null or undefined, I get an error, so it does have to be an iterable thing. I can also skip over things. In this example, I'm saying I care about the 3rd and the 5th thing, but I don't care about the others, and so I use commas to mark kind of placeholders for me. So that's for something that's iterable, like an array, but I can also use destructuring with objects. So here I've got an object, and I want to pull out some of the properties that it has. And so I tell it, I'm interested in that property name and that property name. And when you pull out the values, I want to create variables with these names. But often it's the case that you would be fine creating a variable that has the same name as that property. And so if that's the case, you can use the shorter form. And here I'm declaring 2 variables with those names, but I'm trying to find matching properties in that object and extract their values. So this can be used in a lot of different places. You can use it when you're declaring variables, when you're just assigning to existing variables, in a parameter list. So I've got a function that I'm passing an object to it, but I really want to pull out certain properties from that object. I don't care to have a reference to the whole object. And you can also use this in for of loops, which I won't have time to talk about tonight. Now there is a little bit of an issue with this when you're trying to assign values to variables that you have already declared. And the problem here is that you're not supposed to start a statement with a curly brace. So looking at this last block, imagine that you had removed these parentheses and I didn't have the one at the front. Well, I'm starting an expression with a curly brace, and that confuses things. And so the way to fix this, my assumption here is that I had already declared var1 and var2. So I can't put a letter, a const out there. So if I just wrap the whole thing in parens, that fixes it. And in this case, when I'm assigning to things that already exist, those left-hand sides can be more complicated things. So I can have a reference to a property in an existing object and I'm trying to assign to that one property, or I could be assigning to a particular element in an array. You can also nest the expressions on the left to any depth you want, and so I could have arrays that hold objects and objects with properties whose values are arrays. And for the sake of time, I think I need to jump through this pretty quick, but let me point out this piece right here. You can use destructuring as a quick way to swap values of variables. So here I'm constructing this array on the fly and saying I want to destructure that and assign it to this. Really all I have done is swap the values of those 2 variables. And you can do that with a larger number of variables then too. So here's a good example that shows the deeper nesting that can happen. So I have a kind of complicated array there with other arrays nested inside it. And then I can destructure that array and tell it the pattern that I want to use to specify what things I want to pull out. And so you can visually match that up and see that the value that goes into D is going to be that 8. And what goes into C here? Well, I'm matching up to this array, but I only want the first piece, and so 4 is going to go into C. I think a lot of people, when they first see that, think that this is kind of tricky coding or it looks complicated, but after you see a few examples of this, I think it starts to become kind of second nature. And then here's an example where I have an object and I want to pull things out. What's interesting here is that, of course, the order of the properties doesn't matter. And so I'm saying, well, I want to create a variable called color and another variable called size, grab those out of that object and assign those values. And then here I have a nested object. My team has a catcher and a pitcher, and those have names and weights. So if I just wanted to extract the name of the pitcher, I could do it like this. Here's my team object, and I want to look inside it and find this property pitcher, and then inside that find that person's name. Now it looks like I have two things over here, but I'm really just creating one variable, just the most deeply nested ones. And so I've created a name variable, and it's going to be set to Adam Wainwright. I could pull out more than one thing. So here I want to look for the picture, look for the name, but my catcher has a name too. So in this case, I'm going to have to tell it the names of the variables I want to create. And so the first one I want is going to be called pName for picture, and then CName. And so in this one line of code, I'm able to extract those pieces of data out of the object and then make use of them. Another use for this is with regular expressions. So here I've got this string that has a date embedded in it, and I have a regular expression looking for this pattern, and I have capture groups here. Notice these pieces in parentheses. So the first one says I'm looking for 1 or 2 digits, and then I'm escaping this slash here, because I've got a slash there that I need to find, and then the next capture group is for that piece, and then I have a capture group looking for 4 digits. So when I call exec on that regular expression and I pass it the string, it's going to give me an array where the first thing is the full match, and then the other things in the array are the values of the capture groups. But in this example, I only care about the capture groups. And so I can use destructuring to say, I don't want the full match, but I do want the first capture group, which is month, and then day, and then year. And so that's a very compact way to get pieces of a regular expression. Another place this comes up is for configuration kinds of functions where you need to pass it an object that holds some kind of configuration data. And so rather than say config is a function that takes an options object, I can be more specific and say, yeah, it takes an object that has at least these properties. And you could pass it an object that has more, but I'm looking for a color and a size and a speed and a volume. And by the way, if the object you give me didn't specify a speed, it's going to default to slow. And so in the parameter list, I have destructured it and pulled out just the pieces I care about, and then those become local variables inside that function. Arrow functions, another favorite of mine, is a much more compact way to write a lot of functions. And the general syntax is what you see at the top. Your parameter list has parentheses around it, and then you have an arrow, and then you have a block of code with any number of statements. But there are a bunch of shortcuts that you can take here. And the first shortcut is that if your function only takes one parameter, you can drop the parens. Sadly, if your function takes 0 parameters, you still need the parens. So it's only in the case that it takes 1 that you can drop them. Another nice shortcut is that if you only have one expression on the right, you don't need the curly braces. And also, that expression becomes the return value of the function, and you don't need the return keyword. And the only rule about formatting this is that you can't put the arrow on a different line from the parameter list. The arrow has to stay together on the same line, but your expression or the block could go on a different line. And so here are some quick examples of this. I've got this simple array, and I'd like to create a new array where I double all the values. And so I'm going to call map on my array, and I'm passing it a function. So this arrow function says it takes one thing, and it returns that thing multiplied by 2. It's much shorter than the old way of writing it, where I would have to have the function keyword, and I would need to have curly braces, and then I'd have the return keyword, so it cuts it down quite a bit. Here's another one that just takes 2 numbers and multiplies them. And then here's a short way of computing the average of a bunch of numbers, where I'm using reduce, the existing reduce method in the array class, and saying, here's my reducing function. I just take pairs of values and add them. So these arrow functions really shorten your code. The other thing about them is that they support something called lexical this. And that means that they don't introduce a new value for the this keyword. And it means that if you want to operate on the current object, you never have to do that trick where you assign to a variable like self, and you say like, let self equal this, just so I have a handle on it, and then I can use that inside the function. I don't need to do that anymore because the value of this inside the arrow function will be the same as it was on the outside. And a similar thing happens for using super. Enhanced object literals let you omit certain parts of the object literal. Like in this example, I have the variable fruit, and I have a variable number, and I want to create this object, but because the value I want to assign to this is the same as what's in that variable, I don't need to say fruit : fruit. I can just say fruit, and it means the same thing. And that's what's happening with number here as well. Better speed up to a couple of other points that I want to make sure that I hit here. Another part of enhanced object literals is that when you want to have a function that is one of the properties of an object, you can write it in a different way. So the old way of having a multiply method inside this object would be to say that multiply is a property whose value is a function, and here's a definition of that function. But with the enhanced object literals, I can write it like this. So get rid of the colon, get rid of the function keyword, and just write the function. Okay? I cannot use an arrow function in this context because the value of this here wouldn't be right. It would be whatever this was up here. But I need it to refer to that object. So this doesn't work, but this is really the new way to add a method to a literal object. There are template literals. It's like a new kind of string where you delimit it with backticks instead of single ticks or quotes. And inside that string, you use $ curly brace and then any JavaScript expression you want, and then the close curly brace. And it will evaluate that and insert it into the string. So I have 3 of those in that example. And then the last thing I want to show is how you can define classes in ES6. And this really is just syntactic sugar over what we've always done. We still have prototypal inheritance, even though this is added. It's just letting you have a nicer way to write that code. So here we see an example of a class that represents a shoe. And these classes have a single constructor, can take whatever arguments you want. And as is pretty common in this kind of class, the thing you want to do in your constructor is take what was passed to you and hold on to it in properties of this object that you're creating. So I'm holding on to those 3 things. I'm also bumping up this count. And you see down at the bottom, currently this is how you'd have to define what you would think of as a static property of this class. So I start off with not having created any shoes, but every time I call the constructor, I bump that up by 1. Here I have a static or a class level method that I can call on the shoe class and ask, have I created any shoes yet? Then I have a way that I could compare objects. I'm checking to see, well, is the one you gave me an instance of my shoe class, and do all the properties match? This is not a magic method in JavaScript. You could call it anything you want, but that seems like a reasonable choice. And then I'm outputting a string representation. So down here I create 3 shoe objects. And I ask, have I created any? Yes, I have. And I can get to the count. I've created 3 things, and I can output them. This is making use of my toString method. I can compare them. Of course, the shoe 1 and shoe 2, those aren't the same. They have different brands and models. But 1 and 3 have the same values, and so those come out as equal. And then the last piece of this is that you might want to write a class that inherits from another one. So here I have a running shoe class that inherits from shoe just by using extends. And its constructor calls the superclass constructor just with super. So I'm passing through the things that the shoe class knows about. It holds on to those. And then the one unique thing here is the type. And then I haven't run in these shoes yet, so they have 0 miles on them. And then with running shoes, you want to keep track of the mileage. So I have this method where I can add miles to the shoe. And most shoes should be replaced after you've run 500 miles in them. And so I can ask whether it's time to replace it. So here I create a running shoe, add 400 miles. No, it's not time to replace it yet. But if I add 200 more miles, now it's time to replace it. And so there are a few rules around using this kind of a class. You have to make sure that you call super before you try to do anything with this, because it's really the highest class in the hierarchy that creates it, and this doesn't have a value yet until you call super. Other details that you can look at later about what happens if you don't have a constructor, what does it pretend that you've written, and I'll have all these slides out on my website, and you can get to them later. So thank you very much for listening to my talk, and grab me later and we could talk about anything JavaScript related, and all my contact information is here. Thanks.